We're ready to begin. Welcome to the TEAS interim meeting that is sort of in place of our IETF 107. I'm Lou Berger. Yvonne Biram is running the slides, co-chair. I think we have our Secretary Matt online, or at least if he's not here yet, he will be here. Yeah, great, cool.
I'm here.
Thanks. As always, this is a IETF meeting, so we have the IETF note well. Go to the next slide, please. Oops. Yeah. There you go. So some administrative pieces, and hopefully this ended up in the chat that everyone can see. The slides are all posted at this interim link. The Etherpad, please join the Etherpad. It's actually really important this time. And at least add your name to the end. That's where our virtual blue sheet exists. And once you're there, please stay around and add any notes to each of the slots. You don't have to take notes on what is being presented on the slides, just the conversation that happens afterwards. Really appreciate your contribution there. And by the way, thank you very much for showing for the interim. For the WebEx chat, we'd like to limit that just for queue control. So if you want to be in the queue, say plus Q. If you want to leave the queue, say minus Q. And if you want to chat at each other, we're going to continue to use Jabber for that. The Jabber information it's the usual room. You can find it at the top of the Etherpad if you're looking for it. Next, please. So what's going on with documents in the working group? We had one new RFC, so that's really nice to see. Always good to produce documents. That is why we're here. We have a couple of documents in the editor queue. Some of them are moving a little slower than we'd like, but they are moving through the RFC editor's processing. We don't have any new documents to the IESG, and we have no new adoptions or errata. Next. Our agenda is unchanged from what's posted. What we try to do is focus on what's happening, updates from the design teams and what's going on there, and talk about new things that the working group may decide to work on. For regular working group documents that are progressing, we ask to do status of the list as we usually do. And unlike usual, we're not going to have our normal working group discussions on active documents. We want to have those on the list. And if there's sufficient discussion on a particular topic, we can hold another interim on just that specific topic. We are going to run through what was sent to the list at a high level. Pavan's going to do that. That's next. Okay, next slide, please. There was one liaison that was actually sent. This was joint work with, I should have listed the other working groups. In particular, CCAMP took the lead on the response, so we appreciate that. So that was one outgoing liaison, nothing incoming. Next. As always, we have our formal IPR process. That's just our standard reminder. So as I talked about, we, in addition to our normal use of the working group mail list, we really are for during this time where we're not meeting face-to-face, we think that the list is even more important, and we really want to encourage discussion on, as I said before, on working group documents, but also new documents. If you have something new that you think that you want the working group to pay attention to, please discuss it on the list. Don't wait for the next face-to-face meeting. Don't wait for the next interim. Bring it up and say, hey, this is the topic, who's interested, and try to generate some interest and understanding of what it is that you want to work on. Next. So that's it. I had one point I was going to add, but of course I have forgotten that. I will be watching Jabber, so if you want to speak at the mic, Remember to say plus Q minus Q in WebEx. If you want something said repeated jabber at the mic for some reason, maybe you don't have audio, just put like at mic in front of it in the jabber window. That's it for me. Pavan, over to you.
Good morning, good afternoon, good evening. Hope everyone is doing great. I do appreciate all for taking the time out to join this virtual session during these difficult times. My name is Pavan Biram. I'm the other co-chair for this working group. And as Lou mentioned, I'll quickly walk through the status of some of the working group documents. We currently have 19 working group documents with us. All of them are listed here. As Lou mentioned, none of these are on the agenda for today's session. We had requested the authors of the working group documents to send in the status to the list. Thanks to everyone who sent those in. The documents for which we haven't received any status updates are suffixed with an asterisk on the slide. We do request those authors to send out the status to the list. We have one document in an expired state, and I have requested the authors of that document to send an update on their plans for reviving this. That's the RSVP RMR extension document. The documents that are colored green on this slide have all had an update or two made since the last meeting. So please do go through the status updates as well as the latest set of changes for each of these, and reach out to the respective authors if you have any questions or comments or concerns. The authors of some of these documents would also be starting dedicated threads on the list to discuss focused open items. The authors of the TEAS service mapping document, for instance, they promised to start a thread discussing the mapping to the L2, L3 network models. Please do chime in with your thoughts and opinions regarding that on the list. There are also a couple of documents for which the authors have claimed that the document is working group last call ready. One is the PC native IP document, and the other is the RSVP YANG document. Lou and I will take a closer look at these after this session and then start the process for the next step based on a review. In the meantime, it would be useful if we could get more reviews for these documents. There are also a couple of YANG documents for which the authors are requesting a YANG doctor's review. We will get the process rolling for those as well. You can find the complete set of collated status updates on the remainder of this deck. I will not go through each of these individually here. You can go over them in leisure. If there are any questions regarding the working group documents, we can take them now. Any questions?
Adrian's in queue.
Yeah, thanks. PCCC use cases. I thought that we had come to the conclusion, you won't find it in the list. Oh, you will find it in the list. Okay. Yeah, this continues to be a living document and no intention to publish as an RSC. So I don't know how we actually track that, and maybe it's worth stuffing something in the data tracker to say that, or perhaps it should go in the abstract of the document, just so that we don't keep coming back to it and saying, what's the status?
Yeah, fair enough. We did discuss this in the earlier meetings, and I guess the read from the working group then was that we would keep it as active as long as people want to discuss the use cases, and then we'll take a call on the fate of this at a later stage. I mean, we could continue doing that, or yeah, I mean, as you said, if there's something in at the beginning of the document in the abstract, I think that would make things clear for folks who don't have the history of this document. Is that fair?
It looks like we don't have anyone else in queue.
Adrian, you're next on the agenda.
Right. Do I have to stand in the pink square?
Please do stand in the imaginary pink square.
Right, so I'll stop talking. Those with long memories will remember that we set up a design team to look at revising RFC 3272. And those with incredibly long memories will remember that this was a document written around the time of RSVP TE and MPLS TE, describing the background and the tools for traffic engineering in the internet. So slide. So since 3272 was first published, obviously a huge amount has happened, especially around TE, and the mechanisms that we use have developed substantially. We're also seeing that quite a few working groups are using the term TE, with their best base reference being 3272, which really isn't suitable for that purpose. So the design team is chartered to do a complete revision, obviously using a lot of the old text, but updating definitions, adding new text where there are new technologies, streamlining the historical material, where streamlining is a euphemism for deleting, and tidying up the references, which were quite a mess. Slide. So just to make the point that this issue is very much alive, I did a quick look for recent discussions of the term TE in the routing area, and I came up with this list of 10 working groups that are all mentioning TE in one way or another, and to some extent, and excusably, making their own definition of what they mean by TE according to their circumstances. And the excuse is that they don't really have anything to point to as a decent, stable reference. So we need to address, what does everyone mean when they say traffic engineering? Are they all talking about the same thing? Do they mean all of TE or just some aspects of TE? And that one turns out to be quite important. So some people may mean traffic steering, some people may mean resource reservation, some may mean network planning, and the clarity is missing. There's also a degree to which we tend to reinvent tools and techniques. I think that's because we're excitable engineers, and it's much more fun to write a new tool than it is to read an old RFC. Now, possibly that doesn't matter if you're off in, say, IoT world and you do some new tools. Maybe there's no concern about the overlap, but possibly we can reduce effort and benefit from commonality of tools. Slide. So the process we are using to revise the draft is no longer GitHub and Cramdown. We decided to use that initially, and turned out we were all way too old. So we're using the normal IETF process, where contributors propose changes, and I act as editor, and I merge the changes and post new revisions. That is just so much like everyday use. Yes, thanks, new slide. So where have we got to? Note first that we have not changed the document title. So this is still Overview and Principles of Internet Traffic Engineering. And that the inclusion of the word internet there, I think, is pretty important. So stuff that is off in private networks or maybe deep in underlay networks is not so relevant. We're currently at revision 09, and we've had just 4 of us make substantive contributions to the document. Only 3 of those actually from the original design team. Gert came along and did some really helpful work as well. What have we done? Well, we've turned the old RFC from text into XML. We've restructured quite a bit, moving the sections around. And we've thrown out a lot of legacy material, big bits and little bits. Little bits are things like CRLDP. Larger bits are that we probably don't need to talk about ATM in much detail anymore. We've come up with a lot of new sections for the new technologies. And some of those are still empty. Probably some of those sections are still missing, so that's a good way that people can contribute, either by just identifying missing sections or by suggesting text. But some of those new sections we have made a first attempt at filling in. And as I said before, we did quite a good piece of bashing on the references. Next slide. So what do we need to do? I think there are 2 things going on here. There's lots that we could do in terms of polishing and scrubbing, but there are some things that are actually critical and we need to do. First, as I mentioned, the title says Internet Traffic Engineering. We need to be comfortable as a working group that we understand what Internet means in this context, what we're limited to, and what we include when we say it. We need to continue to prune the text. I think the document is still about 30% too long. It's interesting to note that we've remained about stable through all 10 versions by deleting text to match what we've been adding, but we haven't really managed to cut down the quantity. Fill in empty sections and add new sections, as I mentioned before. And then probably the most important thing is to widely discuss and agree the core terminology. So that's discussed within the working group, but also within across the whole area, and maybe even more widely in the IETF. So what is TE? Next slide. The current draft has really quite a lot of froth to define Internet Traffic Engineering. It's 1.5 pages, which is by no means concise and pithy. I've quoted maybe the most relevant paragraph from that, but even this is very open-ended as a definition. It sort of says traffic engineering is all that stuff that you do when you do traffic engineering. So it may help us to really refine and nail down terminology in probably a new section, breaking out the component functions with just single paragraph definitions. And this list is simply a list for discussion. It's to kick things off. If I was to start writing that section today, I would probably take this list, but I might end up with something else. And then at the end of that, we have to define for ourselves whether traffic engineering means doing all of these things, doing some of them, or doing at least one of them. And maybe it will help us to say that actually traffic engineering is a concept, but we need to use the more precise terms everywhere we talk about it. Next slide. So what are we going to do next? I think that there are three options. We could just say, look, this is too much work. We're making very slow progress. Let's give up. Although, of course, there's no such thing as giving up in the IETF because anyone can pick up a document and work on it. We could continue to work on the document using the current scheme, which is to say it's an individual submission, work continues as normal, and everyone is welcome to contribute. At the moment, we're using a mailing list which has an open archive, so everyone can see what's going on there. But apart from that, it's open for everybody to participate. And we could probably say that the design team has completed its job. So this is an individual draft with open contribution. Or thirdly, we could take that a step further and adopt the draft as a starting point for more work in the working group, formally close the design team, and by having a working group draft, have something a bit more solid that other working groups can point to. And if we do option 3, obviously this would be a good time to start asking people in other working groups who are probably not following this work what their opinions are. And I think at this point, I see Lou standing at the microphone.
I actually came up a while ago, but that's okay.
No, I still see you standing there. Yeah.
No worries. Thanks. So I actually wanted to make a comment earlier as a contributor. We've lost the slides, but on the what is TE, I think you really hit it, because having a short definition that other working groups can look at is really helpful. I ran into this in the beer working group where they have in their charter to do beer traffic engineering and weren't really doing traffic engineering, so have decided to instead call it tree engineering. But I did volunteer to write a short paragraph on how they could make their, or section on how they could make their document really be traffic engineering. And in so doing, I think came up with some a short definition that we could adopt to start that section as what is TE. Again, as a contributor, what's the best way to send that to you, to contribute that?
Email, handwritten on vellum.
Yeah, I have it handwritten in a notebook, actually. I can take a picture and send it.
Yeah, well, no, I can't read your writing. We've established that for years.
Barely read it,
raw text is just fine.
To you, to the design list, to the working group list, what do you think?
I think today send it to the design list, but it depends on which next steps we take and exactly when you send it.
Okay, I'll try to do it by the weekend. How's that?
Yeah, thank you. That's a normal promise in the design team.
Great.
So something you just said struck me, and I think that's for Deborah's on the call and any other ADs as well. It is worth noting then when we charter new working groups and we say something glibly like we will do traffic engineering in this working group, we have to go a bit further and say what we mean by traffic engineering.
Well, they just decided that the work charter doesn't matter, and they'll call it tree engineering.
Whatever. Yes.
Right. I mean, that's for the ISG to do.
We did have in the charter that they were, I forget the exact sentences, but they were to collaborate with TEAS. But the difficulty here is that once it was pointed out to them, it's not a true definition of TE, they decided to come up with their own acronym, tree engineering then. So that's the conflict there.
But from this document's perspective, having a brief, something concise that other working groups can look at and say, this is really what they have to, to focus on these concepts. And if they want to do it, there's a whole slew of details behind it, which is the rest of the document. But something that's shorter than, a 100-page document is really good. So I think you've raised the perfect point in that what is TE slide. Pavan, do you want to talk with chair hat on about the document, about the last question?
Yes. Yeah, I mean, adoption seems like the option that that seems most viable. So do you want we can get started the process after this session?
That would be fine. Can I caution you about the IPR poll that you have said you might do? That if you count all of the design team as contributors, and worse than that, if you count all of the people who contributed to the original RFC as contributors, you'll still be doing an IPR poll in, I don't know, 2 years' time.
Yeah.
How you handle that's up to you, but I just thought I'd flag it.
So Adrian, from the existing the existing authors, we can assume that they abide by the IPR statement in the document that was published. So for the old text, we don't have to repull those authors, but anyone who contributed to the new work and I mean actually wrote text or did something that resulted in text, we need to have those people called out in some way. And we'll have to defer to you and the other authors to figure out how to identify those. The traditional way we do that is, people that are part of a design team but didn't really do the things that translate to text, they go in the acknowledgements, or not at all. That's your call. But people who actually did the contribution show up either as an author or in the contributor section. So if you can make that distinction. Maybe I don't know if it's already there that way. I didn't look, or if you need a new revision to make that would be really great, because then we can delineate who really is responsible for the content and needs to.
Yeah. Okay. I'll do a new spin before you start it up.
Wait until Monday to see if I actually send you something worthwhile.
Okay. Well, revisions are cheap, Lou.
Let's say again.
Revisions are cheap.
Thanks.
Any other questions?
So we're moving on, right? So I think, Yari, you're going to start on the slicing design team. Is that right?
Yeah, if you can go to slide number 2. And can you hear me all right?
Can you confirm that you can see the slides?
I can see the slides. Oops, now it's doing something funny. Yeah, now we go. Good. So we have a little bit of time here to talk about network slicing. And I'm going to start. My name is Jari Arko. I'm going to start with the introduction. And then I'll let Kiran and Eric go through the 2 drafts that we've actually produced. And we have reserved quite a lot of the time for discussion. Let's see how much we get of that. I think what we're going to do actually is that after both of the drafts, we'll stop for discussion on that topic, and then at the end we'll have some further discussion. We could have a discussion on like whether to adopt the drafts, for instance, for the working group. That's the ask from the design team actually, that like the working group to adopt the drafts. We can talk about next steps, relation to other work, whether there's missing pieces, what the working group might actually want the design team to do in the future, and so on. But starting with the design team context, can you go to the next slide? So listening to Adrian's presentation just a moment ago, what I would like to say is that this design team has been working on traffic engineering. But basically, we are to develop a framework of providing network slicing using existing IETF traffic engineering and VPN technologies. And that's actually a sort of a, oops, no, you're jumping. So the task that we have is slightly difficult. I mean, it's in some sense easy, like, you know, just explain how to use these things, and maybe we need to add some things and write documents, but it's made difficult because this is such a hot topic. Can you go one slide back? No, now we're good. Sorry. Slide. Yeah. Now we're at the right place. So it's a hot topic. So there's a lot of interest on, you know, people working on this, and they all, you know, often want to include many different topics under it. But we've had a very narrow definition of what we actually are working on, and Eric and Kiran will talk more about that in a bit. One word about the mode of operation in the design team. So sometimes you have this like closed design teams. This is not one of those. So we actually do everything out in the open. We have an open list. People can join. Calls can be joined. Documents are open. And the list of contributors, people who join the calls, is not the same one as originally selected members of the design team. So we've been trying to be particularly open. I think that will actually work quite well. And of course, design team just makes proposals. It's up to the working group to decide whether you want those proposals or some variant of them. We also don't do draft authorship based on team membership, obviously, because we have too many people, but rather, you know, who actually wrote text for the particular document. So that's how we operate. Next slide, please. So the design team timeline, just flashing this, and apparently some of the graphics is missing, but so in IETF 106, we had plans, scope, and some early contributions that we talked about. And now we have initial definitions and framework drafts in front of you. And the hope is that by the next IETF, if there is one, we would have a stable draft from the design team, and it would be a proper working group document and so on. Next slide, please. And the design team scope and plan is basically, you know, get to the basics of networking here. Explain how to use existing IETF transport technologies, TE/VPN technologies to do this, what we call transport slices, and Kiran will define that in a bit better way in a moment. So we want to do definitions of what is this thing that we would like to achieve. We want to do a framework that describes the overall system, how do the pieces fit together. And then the idea is that there will be, you know, this general framework can be instantiated to use a particular implementation technology, because in the IETF we obviously have a number of different technologies. We'd also like to talk about some of the use cases. We don't have much of that in the current documents, but that could be perhaps a future document. And our status is that we published now the two first documents. So there's a document on definitions, a document on the framework. We'll talk about that in a bit. The mapping to particular implementation techniques, any particular extensions that we might need to control the different components, like a northbound interface, for instance. Those have been discussed, but we don't have a document or particular agreement about the approach even for those things at the moment. We're working on that. And I think, was that the last slide? Can you check?
That's the last slide.
Yeah, so that's basically the context. And if people have questions now, we can talk about that a little bit, but otherwise I'll let Kiran continue with the substance.
We do have one person in queue. Joel, do you want to go now or after the next slot, which is definitions?
Definitions would be much better. Let them present the definitions first.
Gotcha, thanks.
Okay. All right, so I'll shut up and let Kiran talk.
Hi guys, can you hear me?
Yeah, we can.
Great. So the definition part of the transport slice is trying to normalize all the terminology, scope, and the terms that we use in the context of transport slices. And it is the work of the entire design team. They have contributed at some point or the other in terms of adding, deleting topics, and refining the text. Next slide, please. So since we are talking about this document for the first time, this is pretty much the outline and the way in which we have written the document. It has the definitions, some description about it. And since we could not cover everything into the definition, there's a section on characteristics that develops the different aspects of the slices. And finally, we have the structure of the transport slice. Next slide, please. So this definition is not very different from what we had in 107, and it is derived from some of the work that is already going on Enhanced VPN. We tweaked few things in terms of bringing in the term SLOs and dedicated network resources. So the keywords here are logical because we wanted to define the slice in a completely independent manner from any technology that is being developed in PE or elsewhere. We just wanted to give a standalone definition for transport slices. We talk a lot about service level objectives because we want to make it easy to attach what kind of characteristics you want from your slices. They should be measurable, quantifiable, and easy to understand when it goes down into the network. And then obviously we talk about topology and endpoints. That means it is not just a very simple one-to-one logical wire or anything. We actually look at it as a logical network in itself. Next slide. And so the first part is the characteristics about the slices. Obviously, a lot of emphasis on service level objectives. And at least from my perspective, the way I see it, we have two kinds of SLOs. One is metric based, where you can clearly say how much you want, something like bandwidth, latency, and so on. And these are the definitions we took from the existing work in IETF RFCs. We did not try to define anything on by ourselves, and we do clarify that these things are unidirectional. So there's no assumption that whether it's going to be bidirectional. And we also clarify that SLOs are required on per link basis, per flow basis, or group of flow basis. So there's some text to describe how SLOs can be defined. Next slide. So the second aspect of SLOs is from the operational perspective. So just defining latency and bandwidth itself is not sufficient. You would also want to say that I want my network to be highly available, reliable. I don't want any packet losses in it. So there should be a way to describe it and what kind of security parameters do you need. So within security, we talk about encryption, admission control or authentication, and the isolation characteristics that you should not be able to interfere with other slices or other aspects of the network, or other flows that are going on in the network. Next slide. And there was a lot of discussion on the isolation that some people wanted. It should be a top level SLOs, but we didn't feel very comfortable because it's very hard to define what isolation is going to be for a particular SLO. So we came up with a term called resolution of guarantee. In this, we talk about soft guarantees and hard guarantees in terms of, for example, hard guarantee will mean that you have dedicated the resource for or dedicated allocation for that particular SLO. That could be bandwidth or latency or a link itself, physical link itself. And soft will be more virtualization, that you're still sharing resources with other slices or other aspects of the network. And the reason we did not want SLO isolation at the top level is because we cannot guarantee that with isolation you will not see any SLO violations, because violations can still happen if there is a failure in the network, and you cannot 100% guarantee that there will be absolutely no packet loss. So you need to provide different ways of solving those problems. We have written a lot of text explaining these things in the document in the details, so that when you talk about SLOs in the context of transport slices, you have a very good clarity that when a northbound interface is developed, you know how you can add these things into your model. Next slide. So obviously, then an important part of slices is the endpoints themselves, and we allow those endpoints to be either transport time, your type, your switches or routers, or they can also be some sort of network functions which are related to the something like DPI, firewall. These are the things that you would have in your network and you would want to install in your transport slice to perform different functions specific to your vertical. And again, they can be multi-point to multi-point connectivity patterns. We described a section on that. Next slide, please. So, and we had some great deal of discussion that what is that connectivity aspect of the transport slice, and how is it different from the existing technology, existing TE technologies, to be specific. So one thing we say is that transport slices can connect different types of technologies together. And how do you extend them? So there are two aspects. One is horizontal slice and the vertical slice. In case of horizontal slices, we had a use case that if you have, let's say, segment routing in a particular network and you want to stitch with an L2 VPN segment, how would you do that? So end-to-end will become a horizontal slicing solution. Similarly, in a vertical slice, you would like to have something at one level. A slice is created at the optical level, optical layer, and then you want to abstract it up into an IP level. So you would go from lower level to upper levels, and you could do that using vertical slices. And especially in the case of horizontal slices, you may need something like slicing gateways, because you need to stitch to different kinds of technologies together. So we introduced the term slicing gateway, and there is some, we have started working on it, revived some of the documents, and going forward, we will show more details about it. Next slide. And then obviously the structure part of the transport slice only provides some of the terminology that is actually explained in much greater detail in framework document. And the things we talk about is transport slice controller or orchestrator. We want that everybody should use that terminology consistently, not in a different manner. So what is the meaning of NBI and SBI in case of SBI in transport slices? That is covered in this section, and it is always with reference to transport slice controller. And an important aspect that we bring out is the dual aspect of transport slices. One part is the logical representation, how a customer will ask for the transport slice, and then the actual realization in the network. So we could have actually, we can develop the slices in these two parts independently. And what requires in between is the gluing that will happen through NBI and SBI interfaces. Next slide. And then obviously this was actually when we started writing the document, was our first section, where we wanted to say that transport slice is just one part of end-to-end slice. There may be other slices that are done by other STOs. For example, 5G is a great example where they have RAN slices and core slices. We are not concerned with that. We are only focused on the transport and the connectivity aspects. So we have explained through an example at the bottom of this document, so that there is a clarity between what transport slices are versus other slices. Next slide. So that was just an overview of the document, what we have covered. We made sure it was consistent with the ongoing work. For example, the way enhanced VPN document is written. We also make sure that the terminology is aligned between framework document in our definition document. And in fact, we use this document as a reference whenever there is a discussion on some SLOs or other characteristic aspects. We say, hey, we have written this in the definitions document and you cannot digress from it. So that way, this is serving as a baseline document of how transport slices should evolve. So, and it's been in a pretty stable shape from last 1 month or so. If you guys think there's something missing, please let us know. And so we are asking for feedback and maybe, if possible, work group adoption. Thank you. I think this was my last slide.
We have a few folks lined up in the queue. Joel, you're first.
Okay. First, I recognize a lot of effort went into this, and I appreciate the design team's effort. However, there are serious problems with the document as it is. First one I hadn't known until you presented, because your description of SLOs at the beginning was fairly reasonable, but does not actually match section 4.1. Because, for example, there's text about bidirectional measurements in section 4.1, and you specifically said in your opening that it was unidirectional. You need to make sure that the text and your intentions line up. So I'm not going to belabor that. On the rest of this, to save the chairs from telling me, please send this to the list as well, I am in the middle of composing an email to the list. It was just complicated enough that I haven't sent it yet. I hope to get it out later today. There are some very serious problems with the text, the descriptive text. For example, the resolution text talks about hard versus soft, and as you said in your presentation, it's about, well, you can protect against some kinds of failures and not other kinds of failures. A customer doesn't care. A customer wants a guarantee. He knows there has to be some confidence in it, that no guarantee is perfect, etc. But he doesn't care why it was violated. There is no difference from an SLO or SLA perspective between violated because of competing traffic and violated because of device failure, software failure, whatever, backhoe fade. From the customer's point of view, from the user of the slice, and therefore from the abstraction the slice provides, this is a meaningless distinction. And the entire then effort you go to describe resolution doesn't match the way operators write these agreements. I would expect resolution to correspond to the way operators actually have figured out to write these to deliver services, and it doesn't. Then you get to isolation. Isolation is not a security property because isolation is actually not observable. Isolation is a way. As the document says, this document is supposed to be about what is delivered, not how it is delivered. There should be no references to isolation in here. I would suggest removing section 411 completely and removing the reference to isolation from the security section, because in fact, isolation is not an observable. It is a means of achieving a goal. There are many kinds of isolation that can be used. They deliver useful goals. That's why vendors build isolation technologies and operators use them. But there's lots of different things under that rubric, all of which are unobservable and therefore not part of the definition of the abstraction that we are describing here. And I think it is very important that we focus on that abstraction. Thank you.
Yeah, Joel, you made a lot of points and all of them are well accepted. For each SLO, we do mention whether they're unidirectional or not. We have not, we are not saying it in a generic way. So it is in the document, I'm pretty sure about that. Second thing is on isolation. I do agree with you, and that is why it is not observable. And that is the main reason it is not part of our SLO. It is there just as a discussion that what it means. There were
Why discuss it at all? Why discuss it at all? It is not something that this document needs to deal with.
There were a lot of members in the design team. They wanted to have this discussion in the text. One of the specific
It
use.
doesn't make it so. It doesn't belong.
I personally think it brings a lot of clarity to the document, and it is there just as a side discussion. It is not actually part of the SLOs. And some of the interesting examples were where a user may ask for an entire physical link rather than having any shared resource where interference is possible. And that's why
I think we've gotten to the
definition
point
of
where
parenting in terms of hard and soft side slices was an interesting concept to bring it into the document.
I think we're at the point on this comment where, Joel, we really look forward to seeing the mail that you promised us and knew we would ask
I
for.
will deliver it.
And then we should talk through it on the list. I actually have some comments also in that discussion, but I'll take it to the list also.
Fine.
Next in queue is Adrian, and we have a couple more that have added to the queue.
I've
Just so you know,
got
we have a deep queue.
I've got three small points, so I'll do them all at once. First one is there a proposal for how to resolve the conflict between definitions in this work and work that is already adopted and progressing in the working group? Second question is about the word transport, and you can answer this easily by saying, oh yes, we've defined that in the document, but I didn't put it in the slides. But I noticed that the design team task was to talk about network slicing, and that this work appears to have picked up the term transport network slice and IETF transport technologies without explaining to me what transport actually means in this context. And the third question is around the term service level objective. And I know that's a term that's grown in popularity in the industry, but I think it means nothing, because an objective without a guarantee is a wish. And an objective with a guarantee is an agreement. Some of these slides, in fact, the one being projected at the moment, talks about guarantees. So this sounds simply that you're rebranding SLA in a different context.
Yeah, so let's go backwards. So difference between SLO and SLA, the way I see is in the level of granularity. Since SLAs are more at the service level, that you would, when the service is deployed, you say, hey, this is my SLA, and for the lifetime of my service, I want this kind of agreement. But when it comes down to SLO, it is on per flow basis. Then you're responsible for entire flow to behave in a certain manner. And you could have multiple flows in a particular service. They can come and go at any time. So the granularity is different in terms of SLA and SLOs in my mind. And so I don't see any problem with that. And your first question was, how do we align it with the existing work? In fact, the definition, what we have here, at least with the enhanced VPN document, it is very much aligned with just few tweaks where we felt that it should be done that way, where we wanted to tweak it. But the starting definition was in fact from enhanced VPN, and people who are working on those drafts helped us resolve the text here. And the question between network slices and transport slices, the simple answer is that network slices itself, it goes back to our second last slide where we talked about other slices and transport slices. So for you could have different components in network slices, but here we are only concerned with the technologies that are being worked on in IETF domain, and that is where the term transport is used, so that we can leverage the work related to connectivity. That actually comes, a lot of work comes from the TEAS group.
And I can add one more item here. This is Reza speaking. So we decided that the terminology is very important. End-to-end network slicing, as this picture shows, contains a group of transfer slices, and we don't call it transport network slice or other terminology. The terminology that we use specifically, we call it transfer slice. So this one-to-many is a characteristic. Also, end-to-end network slice has other slices, depends on the use case, depends on the technology. As mentioned in 5G, this OS, other slices are RAN slice or core slice. So the terminology that we use, I guess a short summary, even the title of the draft says, IETF definition of the transfer slice. And we want to make sure that this very consistently use this term. We are not using any other term. Any draft clearly described. There are some STOs using sub-slice, slice subnet, and others, but clearly define why we use, and we were very consistent throughout the document using the term transfer slice and nothing.
So thank you, Kiran and Reza. Just to note that your comprehensive answers entirely failed to satisfy me on all 3 points. So we'll take this to email discussions.
No problem.
Please make sure that the document is updated to reflect, because we don't. That's the way to capture the conversation. Just so you know, you have 4 more in queue, and I've cut the queue after that so that we allow some time for discussion, hopefully after the next design team presentation. Hao-Ming?
Hello, this is Hao-Ming, and just 2 more very small additional points after Adrian. The first one is on the very beginning, I think the definition of transport slice is claimed to be logical and technology agnostic. But the question is about whether all the slice must have a kind of TE feature, traffic engineering.
Maybe I can answer that, Kiran, if you don't mind. As you mentioned, transfer slice is a logical description of the connectivity, basically. Whether or not the implementation or realization of a transfer slice needs TE, this is just a northbound to southbound mapping. So at the top level, the transfer slice describes the connectivity plus SLO that connection should contain. How it is realized in the network, maybe we use it using TE technology, or operator decides to realize a different way. So the TE, in the short summary, the TE is basically the technology related for realization. It can be used, definitely can be used, but based on the definition of the transfer slice from northbound, it just describes connectivity plus SLA requirement that's needed.
Okay, thanks. And the second question is about another terminology, endpoints. Actually, this is a very, how to say, widely used term when we talk about connections. There are endpoints when we talk about tunnels, paths, and also slice, we have endpoints as well. So I'm wondering whether we can suggest using very specific, say, transport slice endpoints in the context to make sure that we don't mess up with other kind of endpoints. But when I read the draft, I also see that the endpoint is categorized into transport type and service type. So I'm not sure how to better organize this, but please consider the relationship between endpoints.
But it's just a short summary of endpoint. We had a long discussion at the beginning. At IETF right now, in different contexts, there are terminology like access point, termination point, endpoint. So we went through the whole cycle of this name, and I remember this was the first meeting that we had, and we came up with the endpoint. So we try to be very specific and clear. If it is not the case, we work on the draft, but basically this is a short summary of why we came up with this endpoint. And whatever you say is absolutely correct. There is no black and white description here. You can define it either of those, and logically it's correct. But anyway, this is the reason that we use endpoint.
Yeah,
could
I'm
be
not.
a bit,
Yeah, I'm not asking for a very explicit definition. It's hard for a really endpoint, but because it's a kind of relative concept. What has been in my mind is that, for example, mapping some of the transport slice endpoints to another kind of endpoints is a kind of logic somewhere. But it may vary per application or per implementation.
but if you have anything specific, it would be great if you can say in the mailing list, and
If you
definitely
explain
we'll
it,
take a look at it.
yeah, if you explain it through an example, we can refine the text.
Okay, will do.
We have Italo next on the queue.
Can you go to slide 8, please? Yeah, here I'm a little bit confused by slide 8 and 9 and 10. So my understanding of slide 10 is that the network slice, you have an end-to-end slice, which can be composed by different slices, and one of them can be a transport slice. And then the transport slice gets implemented within a network, which can be one or multiple. So I don't understand why in this case we have the transport slice, which is further decomposed is to stitched or hierarchical transport slices. Looks like this is more implementation, not transport slice.
Yes, so transport slices, that's what I said, that in one of the previous things, that there is a duality concept to the slices. It is not just the description of the slice that a customer wants. In the end, you have to realize it into the network. And how you realize into network is dependent on the kind of technology you have used in your underlying network. And there could be different kind of technologies together. It is not a single end-to-end tunnel, the way we
No,
are.
I agree. So what I would say is that I have in this figure I have transport slice 1, which is a transport slice, and then there are other technologies which are implementing this transport slice in 1. And transport slice 1 can be not a one end-to-end tunnel. You can have 2 tunnels stitched together, or even hierarchical tunnels.
Yes,
I see
that technologies, and the term that is used in 5G and other groups is sub-slices. We chose not to use the term sub-slice and just build from the concatenation or the vertical aggregation of the slices as we go up or horizontally. So that's the main difference here. So you do see the concept of sub-slices in other SDOs. We don't use that terminology.
But one more thing that here is it necessarily doesn't mean that technology should be different. So assume everything in this picture is segment routing. So the whole idea here is a transport slice can be realized by a specific service / tunnel / path, or with another transport slice. This is the idea. Obviously, if you have different technology, so this is another use case of this picture, but it's a combination of various technology or various artifacts you already have in the network. You already created transfer slice in part of the network. You can use it to realize another transfer slice on top of it. So this is the
basically
idea.
You see a hierarchical, recursive hierarchical between transport slices.
Sure, we didn't want to use the term quote unquote hierarchical because that one maybe has different annotation. So we came up with this term, but you can think about that one logically. Yes, yeah. Logically, whatever you said, it's correct.
But if you go, for example, to slide number 9, I could request a slice between endpoint 1.1 and endpoint 2.1, and then I can translate this slide into 2 tunnels, one in network 1 and one in network P, without creating other slices.
Yeah, that is a realization part that you want to do. Obviously, you can do it. So, but if you already have a transfer slice in network 1, you can reuse it. So this is the idea behind that, to be generic and.
Okay. Then you have the challenge of scalability, that for between every endpoint, you will have to define a single logical wire. And what we wanted to do was represent it as a network. So the thing on the top is one slice in itself. with the same SLO.
Okay, so we have two more in queue, Eric and then Jay. Keep in mind, this is both for the question and for the response, that we do have the list to use, and we do have other topics that we want to hope to get to today. So with that in mind, Eric?
Yeah, I can make my point really briefly. I just wanted to address some of the issues that were raised earlier about some of the specific content in the draft. I think it's important at this early stage that a lot of the discussion that was involved and stuff like that gets some airtime. Ultimately, this is a definitions draft, and I'm pretty sure that, you know, between recommendations from the working group and various other things, we can kind of cut down some of the discussion text to much more of a summary, and have actually a really clear distinction between what's the definitions in the definitions draft and what's the background. And I think that will help to improve both the readability and the acceptability of the draft. And I think just at this point, we need to sort of have some of that discussion. And that's it.
Sure. Yep.
So I just want to reply to what Joe mentioned, the question about isolation in his comments. Basically, I think isolation actually was not invented by this document, and we can see isolation mentioned in several previous documents about the VPN requirements and the framework, such as the data isolation or the isolation of routing.
You're breaking up, Jake. I think we lost Jake.
You broke up a little bit, but I think your comment was that isolation is not unique to this document nor invented by this document, and it shows in other documents.
Yeah, and that's correct. And in fact, after a lot of inputs and feedback from authors who were working on enhanced VPN and ACTN documents, this discussion was included, and we found it relevant. So to me, it's fine.
Okay, great, thank you. So I think we're ready to move on to the framework part. Also, I'll note that I cut the queue. I'm hoping we'll have a little bit of time after this one. So if you have additional comments, feel free to make it after get the discussion on the framework document. Or of course, send it to the list.
Okay, so I'm starting now. This is Eric Gray from Ericsson. John Drake and I are the editors for this draft, but we have gotten almost all the work from other places, either from contributors or from other drafts. So let's next slide. So Yari provided us a skeleton late last year, and that was reviewed by the design team during at least one, probably two conference calls. And then one of the things that came out of that was John Drake had said that we could probably get a lot of this text from, for example, from the enhanced VPN draft. And so John volunteered to actually bring that text out and organize it into the outline. And so we did that. I loaded it down with a raft of comments and some of the things that were really not appropriate for this particular type of draft and so on. And then we had a lot of comments from other people. So in fact, we had some comments on relationship between this draft and the enhanced VPN draft from Zhufang and G. And then we were appointed as editors. We volunteered, or I volunteered us, and Yari said okay. And then so we got a bunch of comments from Drew that actually put in as a pull request. A lot of the initial work is being done in this draft and in the definitions draft in GitHub. And so we got a pull request from Drew Doty that we ended up putting in a different section than he had proposed, but we used a lot of that, and we had a ton of text proposed by Razorrick, a lot of which we did end up using. We had a number of other comments from other people in the design team. So if you look at the draft, we're basically listing the the active members of the design team, which is quite a list, as co-authors. And the next slide. So in introducing this draft, I mean, it's important to understand that this is a framework draft. This is sort of like, here's the background, here's the problem space. It's not about requirements at this point. It's not about architecture, although in both cases, there will be some, limited connections. For example, we refer to an architecture in the enhanced VPN, and we refer to the ACTN work. And we don't include requirements language, at least not on purpose. And we do not have the reference to BCP 14, 2119, and 8140, or whatever it is. We have an interesting error spelling correction here on the second sub-bullet here. So this is supposed to be implementation and technology agnostic. It's not supposed to be implantation. And but they are talked about at a high level. It's appropriate for a framework draft. And we include examples from technologies. And then this introduction provides the background, and this is supposed to be ran on all caps. It wasn't intended. And that's as an example, because we recognize that there are other applications that are crying out to use the term and concepts of network slicing. And then we described some applications and how they relate to transport slices. A word on transport slices, which came up during the definition draft. The one application in particular uses the term transport network slices. But we are not talking about exactly what, for example, 3GPP talks about with the transport network slices. So we have sort of shortened the term in hopes to kind of make a clear distinction. So next slide, please. So there's a section on objectives. There's a section on framework, even though it's the framework draft, and there's the section on applicability of ACTN. So the objectives are what the transport slices are and what a transport slice service is intended to provide. What we need in the transport slice controller, for example, to make transport slices useful. And they are creating, modifying, and removing transport slices and monitoring the status and performance of transport slices. And that stuff is there. And then the framework section provides more specifics about a framework. And we describe the slices and the systems that they're part of. We describe management applications at a high level. And we talk about the need to have a way for a transport slice user to talk to a transport slice provider, and that is the transport slice controller and its northbound interface. And then we have some underlying technology examples, and the section on applicability of ACTN terminology to the terminology that we're using is sort of a mapping section. This is kind of an answer to an Adrian comment earlier. And there's actually a figure in there provided by Drew Doty that just shows the mapping. These are the terms and concepts used in ACTN, and these are the corresponding terms and concepts used in this particular work. Next slide, please. Okay, then there's a section on considerations, which, among other things, incorporates the boilerplate required considerations like security and IANA and now privacy. And then it also has the monitoring considerations, which is close to management considerations that has been included in a lot of drafts and RFCs. And so it's just lumped together in one consideration section with subheadings. Okay, next slide, please. So what we're hoping to do is request a working group adoption of the framework draft. There is a normative requirement in the working framework draft on the definitions draft. So if we were to adopt this draft, we'd have to agree sort of in advance that we will eventually, if not right now, we will adopt some version of the definitions draft. I personally think it'd probably be a good idea to do them at the same time. That would be the way I would go with it. And then the draft location is there, and the current version is -03. The latest revision was a very minor revision, fix a couple of typos, and update the reference to the definitions draft. Any questions, comments? This is the last slide.
I'm hugely surprised that given the size of the queue on the last one, that we don't have a large queue on this one. Maybe people just haven't gotten to reading it. That's like on the definition.
Maybe it's because I fed the description to them from a fire hose.
So we don't have anyone in queue now, but we do have time, and we said that we would take questions on the whole design team now. So Eric, if you don't mind, we're going to open up to the wider conversation. Is that okay with you? Or do you want us to talk specifically about the adoption?
Since there was not anybody in the queue when we got to the end of this presentation, and there doesn't seem to be anybody jumping in it right now, I think we just open it up. I'm going to go on mute for the meantime.
Okay. So at least one person had typed into Etherpad rather than coming to the queue after it was cut. If you'd like, please join the queue now. All right, so we have Reza in queue.
Just basically summary of our request, and I think this was agreed during the various discussion and meeting that we had. We wanted to go with the adoption of these two documents. I think this is important for us to, at least if there is a strong objection not to do it, if we can go with the adoption. So this is basically the comment, and I think this is basically the resolution that we got from agreement in the design team.
And that was the position coming in. Okay, understood. Any other comments? Okay. I think based on the level of discussion, by the way, I didn't have a chance to sync with Pavan, so he can jump in, disagree, but based on the level of discussion, my inclination is to take a look at the email comments that come out after this interim, and maybe give people a little bit of time to get them out. You know, it's not instantaneous. And then let's get those comments addressed first and then move to adoption. And it seems to make sense to me to move the documents together. So that's sort of where I think we should go. Kira?
So where will the discussions take place, on NSTT mailing list or on the TEAS?
TEAS, absolutely. The design, not the design team list is not the right place. It should be on the working group list.
Okay, thanks.
Clarification. Pavan, do you want to add anything? Feel free to disagree.
No, I mean, given the questions that came in after the definitions presentation, I think we should weigh in the opinions that come in and then proceed to the next stage. Yeah, let's have a discussion on the definitions, sort it out, and then.
Yeah. So for the people that raised comments, please try to continue the discussion on the list. Authors, please try to address what you heard today in your next version, and then address whatever else comes up on the list. And once you think you have a draft that's ready for adoption again, please send a summary message to the TEAS working group, obviously to the chairs also, saying here's how you resolve the issues and you think you're now ready to move forward. We can see whether that triggers a second round of discussions, or whether if it's not a lot of responses, we adoption.
Fair enough, Luke. So we go through the comments set together and address them accordingly.
Great, thank you so much.
No problem.
Okay.
Next to Mathan.
Sorry, was that a question?
Sorry, this is Igor.
I just want to suggest to take a look at on what Joel has to say, okay, before we discuss the adoption.
I think that's what we just agreed to.
Yep.
Okay. Dan King needed to leave. He typed at me who was going to present in his place, and I have forgotten who it is. Maybe
It's me, Italo.
Oh, okay, great. Thanks, Italo. Yeah, I wasn't sure.
Okay.
So, over to you.
Okay. Thank you. I'm Italo Busi from Away. I'm presenting on behalf of the co-authors of this individual draft, which are listed on the front page. Next slide, please. So what is the motivation of the slide? This document is basically trying to describe some of the key use cases where ACTN can be used to support packet optical integration, and looking at what needs to be supported from both the optical layer and the packet layer, and how the two layers can be coordinated in a hierarchical architecture like ACTN. And therefore we describe how, and then the intention is to basically do some applicability statement or analysis of which YAM model can be used between the MDSC and the packet and optical controllers, and check whether we have any gaps. So if something is missing in the existing YAM models that would be useful to address these requirements. And whether there are additional issues to consider like operational and security. Next slide. The use cases that we are currently describing are seven into three categories. One is about the multi-layer topology coordination, so discovery of the topology and tunnels and services in the optical and the IP layer, and provisioning of links or parallel links like lag over the optical layer, or with or without path constraints, and adding or removing members from logical links, parallel links. And then we have other set of use cases about the multi-layer coordination. So once you have a failure, the protection can happen in between in different layers. So we check the main scenario that requires coordination is how to ensure resiliency when you have a maintenance events. So you want to do maintenance in one layer, what action should the other layer do? Or when you have a router port failure, which cannot be protected by only by the WDM. So in this case, you have to have the two layers to coordinate together to recover the traffic. And then we have also the possibility to that is required to set up services over packet optical and exploit the multi-layer to basically set up the best path across the two layers to support some layer 2 or layer 3 service request. So how the two layers are coordinated, so how the service request triggers a multi-layer path setup across the two layers. Next one. Okay, the reference architecture is basically trying to address both multi-domain and multi-layer. So we assume to have an optical network, two domains, two optical network domains and two IP network domains controlled by 4 different PNCs, and all of them exposing a ACTN MPI interface to an MDSC, which is therefore responsible for both multi-domain and multi-layer path setup and topology discovery. Next one. So what do we have? Okay, after the last in the last 2 meetings, we had 2 drafts which were addressing the problem of applicability of ACTN to packet optical, and we have agreed to merge these 2 drafts into this draft. So the version 03 is merging also the content from the former draft 00 that was presented a couple of meetings ago. And what do we do in this moment? We discuss how we discover links and tunnels. In particular, we describe and clarify the use of the T topology and the plug ID for the interdomain link discovery, and how the plug ID can be used and populated with the LLDP. And we describe the different YAM models that are used at the different MPR. In particular, we exploit the advantage of the work done on IETF that most of the models are common. So we show what are the models which can be, the same models can be applicable to both optical and DAP packets, and which model are specific for optical and which model are specific for packets. And then we are discussing also some coordination when you create a layer 2 or layer 3 services using the service model. Next one. What do we do? Well, okay, we have a lot of work in front of us. We are capturing all the open issues on the GitHub area. And what some of the open issues that we are going to address are cleaning up a little bit the text. So at this moment in time, we just pull out the text from the draft lib. We have to a little bit align to make it more than one document rather than two documents put into one a container. And we are discussing some other options versus in addition to LLDP to discover interdomain links. And we have a requirement from operators to discover some data about inventory, and we are trying to understand what is missing and what is the real requirement, and maybe we have to do more work on the operational and security considerations. So it's just an initial work. Next one. So what is the question? Okay, everybody is welcome to join this work. But we are wondering whether, do you think this document is useful for the TEAS working group? So whether the TEAS working group should basically work on describing these key use cases and analyze how SCTN can be used to address them. And if you think it is useful, maybe we can adopt this document as a working group document and move the change control to the working group. Question and comments are welcome. Thank you.
I don't see anyone in the queue, and it's a little hard to gauge the room. We talked about maybe doing a virtual hum or an adoption. We're trying a virtual hum in NetMod. We'll see how that goes. And so Pavan and I will talk and either do an adoption or a virtual hum.
Okay, good. Thank you.
Sure. Thank you. Assuming we don't have anyone in the queue, Shasang, I think you're next.
Hi. Hi.
Good.
Hi, can you hear me? Hi, good. Hi, this is Xuesong. Good. This is Xuesong. I will present our work about 5G end-to-end network slice mapping from the view of transport network, representing other authors of this draft. And other authors are listed in this page. Next slide, please. Next one, yeah. Driven by the new requirements of 5G, the concept of network slicing is introduced to provide a logical network with specific capabilities and characteristics, which has already been discussed in the previous presentations. Different applications with different requirements can use different network slices. Generally, a 5G end-to-end network slice is composed of three major parts: the radio access network, transport network, and the core network. So when we try to build up a 5G end-to-end network slice, how to establish the mapping relationship between the transport network and the mobile network becomes very important. And our draft is trying to solve this problem. Next slide, please. Yes, the core of end-to-end network slice mapping is to find the relationship of different network slice related identifiers. There are a lot of identifiers, and we list these identifiers in this page. Some of them have already been defined in 3GPP, and some of them is introduced by this document. These identifiers could be used in management plan, control plan, and or data plan. First is the NSI. means network slice instance, which is end-to-end network slice defined in management plan. And NSSI means network subnet instance, which is the network instance defined in the management plan of subnetwork. For example, the AN NSSI and the CN NSSI. Next is TN NSSI means transport network slice instance, which is the network slice defined in the management plan of transport network. The concept of TN NSSI is introduced by our draft, and it follows the terminologies in 3GPP, just like AN and CN. The next is the SNSSAI, means single network slice selection assistance information, which could be used as end-to-end network slice identifier in control plan. TNSII means transport network slice interworking identifier, which is used for mapping end-to-end network slice into transport network slice in data plan. TNSII is a concept introduced by this document. And also we introduced another concept, it is TNSI, means transport network slice identifier, that is used for network slice identification inside the transport network of data plan. Actually, the description of some concepts from 3GPP in this page may not very precise, because some of them are even not clearly defined in 3GPP yet. But we have tried our best to read the documents of 3GPP and talk with 3GPP people to make sure that these concepts are used properly in our document. And we see that we have defined some new concepts, including TNSSI, TNSII, or TNSI. It doesn't mean that this document will define new signaling protocols or encapsulations. It is just for convenience of description about the procedure of network slice mapping. Okay, next slide. There have already been some works in 3GPP about end-to-end network slicing, but the view of transport network is missing. This document provides the supplementations and tries to cover the missing part. The overview of the end-to-end network slice mapping is shown in this picture. In the management plan, each domain, including AN, TN, and CN, will set up subnet network slice to satisfy the requirement of end-to-end network slice. In control plan, an application is supposed to have some specified service will select the proper end-to-end network slice when the PDO session is set up, which is not relevant to the transport network directly. It happens in the between the AN and the CN. And in data plan, when a packet goes through the edge node of each domain, there should be some identifiers inside the packet to map it from one subdomain network slice to the other, in order to make sure the end-to-end network slice is provided. So TNSII is introduced here for slice mapping in data plan. And the following slides show the details of the mapping procedure. Next page. Yes. Here is the procedure. In the management plan, NSMF receives the packet, receives the network slice request from CSMF. NSMF split the NSI requirements to each NSSI, including AN NSSI, CN NSSI, and TN NSSI. And NSMF sends the transport network slice requirement to TN NSSMF. TNSMF allocates TNSSI and sends the result to NSMF. NSMF acquires the mapping relationship between NSI identifier and TNSSI identifier. Also, NSMF maintains the mapping relationship between the NSI and SNSSAI. and also the mapping relationship between TNNSSI and the TNSII. Sorry, it seems a little complex, which could be used to set up mapping relationship finally between SNSSAI and TNSII. Next slide. Maybe we skip one. There's another page. Yes. And in control plane and data plane, when a PDO session is set up between AN and CN, and SNSSAI is selected for PDO session in mobile network, the AN and CN edge nodes encapsulate the packet using the TNSII. We have just defined according to the SNSSAI. The edge node of the transport network parses the TNSII in the packet and maps the packet to a transport network slice. It may encapsulate the TNSII into the packet, and the nodes inside the transport network forward the packet inside the corresponding transport network slice based on the TNSI. Next slide. Here we try to list all the TNSSI options for data plan. It is used in the packet between mobile network and transport network. So the encapsulation should be visible for transport network. In there 2, maybe we can use VLAN ID. In there 3, we can use DSCP, IP destination address SRv6, or even IPv6 extension headers or MPS label. Upper layer, maybe we also consider UDP source port, which is mentioned in other relevant documents. Actually, here we just list all the possible options for TNSII, but there is no preference for these options, and we just try to list all of them and give some technical considerations for each option. And next slide. Okay, go back to the motivation of this document, why we write this document. First, this is not a standard track document. This is informational. And we just want to give some guidance for service providers about how to deploy 5G end-to-end network slicing. And we try to promote cooperation between IETF and 3GPP in the topic of end-to-end network slicing, and also help to discover whether there are gaps in implementing end-to-end network slice mapping. Next slide. What is the next? First, we published this document in TEAS working group, but we are not sure whether this is a proper home for this draft. So we are still trying to find a proper home for this topic and this draft. It will be great if people in TEAS will be interested in this topic, especially the design team for network slice is in TEAS working group. So maybe TEAS is a very good choice for us. And also we still are collecting more feedback from working group and operators, and we will revise the draft based on the comments. Okay, I think this is the last page.
Can you go to a slide for just a clarification based on the discussion that we had previously for transport slides, and I just want to map this picture to whatever you've seen there. So this terminology that is used here is heavily 3GPP. The term in a specific that it's concerning, at least us, and it relates to transfer slice, is term TNNSSMF, Network Sub Slice Management Function. Basically, this box is the box that we call it transfer slice controller. So I'm trying to say that all the terminology that you see here they basically should reference, at least from the transport side, to whatever in the transfer slice we have, the name of transfer slice, using transport, all the things that's related to that. So this is a general context, and I want to make sure that at least for the audience, when they see this picture, northbound of the TN NSSMF, which is NBI that we are referring, and we will discuss that one momentarily, and southbound of that one is basically this box in the middle. So this is a general observation of this one, the terminology. If you want to continue with that, in my opinion, it should reflect whatever is already discussed in the NSDT. And the other comment here is that, in my opinion, this is talking about the data path and how the traffic should map to various transfer slices based on the discussion that we had before. Is TEAS the best working group for this one? I don't think so. I think this is mainly related to DMM, maybe, which basically you are using infrastructure that we are building here in your advantage to say what are the options, and you summarize it in page 7, which is correct, all the things is applicable. So basically one comment and one suggestion. Thank you.
Thank you, Reza, for your comment and question. The first one about the terminology. Actually, this is we have already considered that whether it is good to reuse or follow the terminology from CGPP directly. You have just mentioned, just like the NSSI or NSMF, they are all terminologies defined in 3GPP. Maybe they are not suitable for IETF people to read. Actually, we have already mentioned in our draft about this question. We are open about how to define these terminologies. Basically, the name is not the core content of this draft. We just want to say the procedure. So we just reuse the terminology from CGPP just for convenience in our first or second version of this draft. If there have already been some identification or terminologies defined in the working in the other document from the design team or from other people, maybe after the adoption, or how to say, maybe after we have come to agreement about these terminologies, we can use it in this document. Because if what we have defined in design team haven't been accepted by other people, we use it in this document, will also cause some confusion about the meaning of each terminology. So for convenience, we just reuse
we're actually running really tight on time. So this is a good, I think we raised the point. We can talk about more on list. We have 2 more people in queue. If they can raise their issue, we can address quickly and then move on. That would be great. We're already, as I said, we're already over.
Okay. I think a brief response for the second question from Reza is whether it is suitable for discuss this topic.
We have to take it to the list, or else we won't.
Okay.
Yes, thank you. I really appreciate this work, because I think the draft hits the key problem for transport slicing about the mapping issue. But on slide page 3, I'm a little bit shocked to see the kind of data plane, because if we only talk about the mapping between end-to-end network slice to the transport network, that would be still many layers between the top of the transport network and the data plane. And given the fact that usually the data plane is also multiple technology. Okay, I'm speaking as an optical expert. So given the data plane is multiple technology, we may have different kind of mapping solutions, and we need to organize the physical network very carefully to coordinate with each other. And what has been raised in page 4 is only an example for packet. but not for connection oriented.
If you could
I
respond,
agree.
Need to
Maybe
further work on
otherwise
this.
we won't have time for anyone else. Eric?
Just I wanted to make a real quick comment about Reese's first part, and I know we're going to talk about that on the list, but my comment will be, I think it needs to be talked about on the list, and if nobody else does, I'll start the conversation. The other thing is I have a clarification question about, I think between slides 5 and slide 6 or something like that, where we're talking about a network slice identifier and the possibility of having it included in the encapsulation in the transport slice. So, are you talking about seeing some logical sense? Or are you talking about actually explicitly putting some sort of an identifier into an encapsulation? Because that would involve developing a new encapsulation, therefore a new technology.
Lou, you want
you want
me to answer directly or take it to me?
To be fair to the previous question, I think we have to have the same response, which is, can you please ask the question and respond to the list?
All right, fine. Thank you.
Okay.
Yeah, from the chair's point of view, yeah, the current focus for the working group is to get the design team documents adopted. You can continue discussion of this document on the list, and we will revisit the next steps for this after the design team documents get adopted.
Okay, thank you. And please, all the questions I haven't answered, please take it to the mailing list. We are open to discussions and welcome to other comments. Thank you.
Yeah, so you should feel free to respond without waiting for the question to be sent, because I've already asked the question. You can just respond right to the list.
Okay. I can respond it directly in the mailing list. Thank you. Thank you for the questions and the comments. Thank you.
You're up.
Thank you, Charles. Can you hear me clearly?
Yes, and if you can try to do it in 5 to 7 minutes, that would be great. Thank you.
Okay. I'll take time. Okay, so
if you can just focus on the changes as opposed to running through the solution again, that would be.
Okay. So this is the draft about the RCPP extension for support of proactive protection. So next page, please. Yeah. So the main idea of this draft is that we introduce a new protection method named proactive protection, which means that when we predict a failure, then we will, before the failure happens, we will create the protecting LSPs for this LSP. So in this case, we don't need to have twice resource for the whole lifetime of the LSP. And the main changes include, the first one is we move this draft from the CCAP to TEAS as agreed by TEAS chairs in the last IETF meeting. And the second change is that we try to use the explicit style for the tearing down of the protecting LSPs if the predictive failure at last doesn't happen. And the last change is that we add Dr. Bing from ETRI as one of the authors because of his help on the improving of the solutions. Okay, next page, please. Yeah, so here I want to clarify what is the failure prediction. So actually, before a physical failure happens, there will be always some indications. For example, some of the value of the parameters are changing very quickly, as shown in this picture. But one of the concept difference between the predictive failure and the traditional SD or SF is that the predictive failure happens, that is still under the threshold of SD and SF. That means that there is still no impact on the traffic of LSP. So at the source at the destination end of the LSP, it cannot detect this kind of predictive failure. So that's the reason why we need this kind of notifications. Okay, so next page, please. Yeah, so this is the main idea of the proactive protection. So before T1, we only created the working SP, and at T1, when we predicted that a failure will be happen in the very near, then we will create a protecting SP at this at T1 at this moment, and then at T2 or T3, then if the real SD or SF happened, then we can trigger the 1+1 or 1x1 protection switch to protect the SP. So this is the main idea. Next page, please. Yeah, there is another case that, for example, if the see the top right of the slice, if the digger is going near to the fiber and then going away, so the node may detect the threats to the fiber will disappear. Then the intermediate node can notify the source node to tear down the protecting LSP to save the resource at T2. Yeah. Okay, next page, please. For the protocol extension is a simple. The first extension is that we add two bits to the protection object to indicate each node. To enable each node to start the prediction function to predict failure. One of the bit is for the end-to-end protection, and the other bit is for the segment protection. And yeah, next page, please. And the second extension is about the notification. So that, for example, if the node B in the picture at T1 it predicted a failure, then it need to notify the source node A about this predicted failure. And in this notification, two messages are carried. One is the predict failure ID, and the other is the cause of the predicted failure in the test format. So this message will trigger the source node A to start creating the protecting SP.
1 minute. 1 minute.
Okay. So next page, please. The second extension is for the notification is that if node B finds that the predict failure is not cleared, then it will be notify the node A this event, and the node A can tear down the protecting LSP to save the resource. Please note that this option is tearing down is optional, depending on the policy of in the node A. Okay, next page, please. Yes. Okay, so next step, we'll continue to work on the solution, and your comments are always welcome to help us on the improving of the solution. Thank you.
We have Matt on the.
Yeah, thanks. Can you actually signal the protecting LSP and get the data plane programmed end to end fast enough for this to be useful?
Matt, they're not really introducing any new protection mechanisms here.
No, I'm asking. I know they're not introducing new mechanisms. I'm just kind of, how long do you have to respond to your early warning of a failure compared to the time it takes to set up a protecting LSP?
Yeah, normally.
I think we should take the response to the list if you don't mind.
One more quick.
Please just go ahead and respond. Pavan, go ahead.
One additional point. You are in terms of protocol extensions, you are defining two flags in the error spec, and then the two flags in the protection object. The two flags that you are asking for in the protection object, those typically are carried in the LSP attribute when you are trying to characterize the attribute for an end-to-end path. LSP attribute is the object that we. You can respond to this comment on the list, but yeah, take that into consideration.
We're ready for the last slot, and you have exactly 5 minutes, including question time. Sorry about squeezing that.
Thank you. Can you hear me?
Yes, go ahead.
Okay, thanks. I'm here to represent, my name is Bo. I'm here to represent transport slice model, representing the other authors. Actually, this draft is about, next slide, please. This draft is right. We are trying to define the echo to the transfer slice definition, the design team's output. Like they already gave some definition about transfer slice. So we are thinking, considering, and also the slice definition framework in quite stable. So we are thinking maybe it's the right time to define the NBI transfer slice northbound interface YANG model. We are thinking of from the several way to define this, like from the definition has described the transport slice is an abstract topology, and also they have some SL policy they just presented, and also framework mentioned this NBI model should not only support the configuration to do some like endpoint information and also status for this transfer slice. So next slide, please. Yes, this one. Considering of the like designing this northbound interface YANG model, we are thinking and given the definition gives some nature of the transfer slice definition, like this YANG model should be abstract one and should be technology independent. So we are thinking whether there's some existing model can fit into this transfer slice model definition. So we have considered about the like WIN model. WIN model is a virtual network. It has been doing some abstraction, but when we like when we deep a little of detail, we we find that this WIN model actually they use a T topology model to use together. This WIN is actually an abstract node of a T topology. So we are thinking then this may relate it with some realization given the definition draft has just presented. They also give some clarification that they don't want to be T bound tightly. So we also think, also consider about the 8345. It's a very abstract network topology model, and we also when we analyze it, we think it's described the fully detailed network topology. So we also think when we're trying to augmenting this model, we also face some complexity. So given we have those analysis, so the authors prefer to define a totally independent model to show the customer view of this transport slice. So next slide, please. This is the current transfer slice model components, and also we are thinking what kind of customer view of this transport slice is. So we are trying to define that like this is a transfer slice example in the right-hand side. Like there will be endpoints that will be linked to the customer sites. So in this way, customer doesn't need to like be involved into the details of the transport network in realization, like those tunnels or VPNs. They could only care about how their endpoints being connected and how can their transport, like SL being policy being defined, and then like whether if they have some different SLO, we can use transfer slice as a group to do that. So we also give the definition about these different components in the left-hand side. So the like transfer slice endpoint, the logical endpoint, identify the access point, and TS member is a logical connection between any two TS endpoints. It's a point-to-point and unit direction. It's a logical one, and also the SL group. I don't want to touch the detail of that so far, given I have not so much time left. And next, please.
Yeah, you're actually out of time, so maybe jump
yeah,
to the last slide.
I will jump to the open issues right now. Yes, lecture. We actually have some discussion in the design team. Right now we have some this modeling designing issues, like whether it's a brand new model or augmented model based on existing IETF model. So this is a question we like to hear from the working group. And next one is transfer slice endpoint definition. We also give some definition in the draft, so you can take a look on that if you have other thoughts. And the other thing is whether the transfer slice should support different SLO in the same slice. And I think Eric Gray also proposed that issue to the design team. So and he also suggested that the definition draft can do this, whether the different SLO needs to be met in a single slice. So this is the current issues we have been discussed, but we are still in discussion. So right now, I think this is a very initial draft. So we are here to collect feedback from the working group to see if we welcome everyone have review our draft and give up some comments on this.
Thank you very much for presenting the work. We do have some questions. We unfortunately don't have time, but as you said, you're here to generate interest, and I think you've done that. And we asked for the discussion to go to the list, and really appreciate the contribution of you and also of everyone else's work that was reviewed today, and of course all the working group participants. With that, we are actually out of time, a couple of minutes over. Based on the working group discussions on the list, we can schedule another interim no matter what's going on with 108. And if you are interested in interim, feel free to contact the chairs. Feel free to also send it to the list. We don't mind having those discussions publicly, but if you want to do it privately, that's okay too. So thank you all. I really appreciate it. Pavan, anything you want to add?
Thank you. Hope to see you all in person sooner than later.
Bye now. Thank you.
Bye, everyone.
Thank you.
Bye.